So, hello everyone, and welcome once again. I am Mehak Bhatia, part of data science team at Analytics Vidya, and I'll be host for this session. And Archit will be the chat moderator. We are thrilled to have you guys here with the session full of learning. For those who have joined the session for the first time, a brief introduction to them. A DataHour series is a series of webinars conducted by Analytics Vidya and led by the top industry experts. It's a fun way to understand the concepts of data science from the leading players in the data tech domain. Okay, so we are helpful and hoping that these sessions will bring you some enrichment and learning for all of you. And now coming to the session, which is building data pipelines on GCP. Okay, so deciding the right pipeline architecture for our data will not only give you a rational analysis of your data, but will also help in predictive analysis. In this data, Jaspreet will explain all about building robust data ingestion techniques and using managed services provided by Google Cloud Platform, including building data lakes using Google Cloud Storage and ingesting real time using pubsub, dataflow, and bigquery. Okay, so are you guys all excited for today? Yeah, okay. So we hoping that this session will be full of learning. Okay, then before we kick off things, then a brief recap to the housekeeping items. Firstly, we are recording the session, and the recordings will be available on our YouTube channel. The link is shared by the Archit on the chat section. Okay, so please look at that, and please use the Q&A section for asking any questions in between the session. We'll be doing our best to answer them. And lastly, we'll be share a feedback poll towards the end of the session. You are requested to kindly fill that poll so that we can come up with more sessions like these. Okay. So now on to our speaker, which we have Mr. Jaspreet Singh with us. So hello, sir.
Hi everyone. Very good afternoon.
Yes, sir. So a brief introduction about him. He's a cloud data architect and even we partners. So he has been a data engineer and a cloud data architect for almost 10 years now, and with leading companies including Tevent, Emerson, and Barclay, etc. So Jaspreet is a professional in devising and configuring well-architected decision system platforms through cloud-based frameworks for various domains such as banking, retail, telecom, health and life sciences, media and entertainment, etc. So now I will head over to the Jaspreet. So over to you, Jaspreet.
Thank you very much. So yes, so I would be presenting on the concepts of building data pipelines in modern times. So everyone, do let me know if you can see my screen. Okay, so I am assuming it is visible to everyone. So before we even get into the concept and the process of building data pipelines, I think it's important to understand the need and why there is so much fuss around the data, especially the organizations and companies these days. They want to build everything around that is centered around data. They want to make decisions. They want to see on what metrics, what KPIs, what data. So they want to they want to have everything that they are doing data driven. So I think I will briefly go into that part first. So I'll be touching upon these points basically. With organizations going data driven, and decision intelligence is the present and the future as well. And data is a new eye of the companies. Data generation being all-time high, whether it's being done consciously or unconsciously, and agility to build new things it has gone all-time high, and plus it's all managed through the cloud platforms that we have, and GCP is one of them. So also raw and unstructured data generation is all-time high. So I mean, going back 10 to 15 years, there were organizations who were not that much data driven. The reason being, the limitations on the, unstructured data being freely accessible, contrary to modern day, we have platforms like, Twitter, Facebook, and we have platforms, like news websites, weather websites. So it's all in there. Data is getting generated freely and it's getting freely distributed. And so naturally, the drive of big organizations is towards harnessing the potential of this data that that gets generated, and inculcating a culture of making decisions based on the analysis of that data. And so it's kind of all the observations that are going on. It's important to make those observations. It's important to build those tools to that can enable the data getting generated into getting converted into meaningful information, okay, that can be consumed by the industry leaders or organization leaders to make decisions, right? So conscious and unconscious, why I am saying, because imagine you are traveling, you're traveling through air, you're traveling on the road, you're making bookings, you're making reservations, and you're paying, for example, toll tax on the way. So it's kind of a lot of transactions you are doing unknowingly, that companies are making use of to make intelligent predictions. So unconsciously and consciously, data is getting generated, and it is in raw and unstructured form. And that is the reason the drive has become more inclined towards capturing, ingesting, and understanding that raw data and making informed decisions on top of that. So yes, so any organization, before they can consume or make some inference from that data, they need to ingest it. They need to have it on their platform. And so there are some questions, as you can see on my slide. These are important questions that any organization that is embarking upon any data project needs to answer. They should have these questions in mind, and they should have some answer before they start ingesting and extracting and loading data into their platform. So what they are, so first question is, what are you ingesting? It is important to understand, what data needs to be ingested, whether it will have some business value going forward or it will be losing the business value, right? So those, because the cost of storing data naturally comes into play, whenever you will be building some data platform. So how much you are ingesting, that again is an important question to be answered, because the storage cost, the dollars that you are paying on storing that data, that also needs to be analyzed, and how fast you need to ingest, whether it's a real-time ingestion you are doing or there is a latency, or it's a latency based. Now, real-time is like, let's say you want to read some data from the equipment, sensors, or, sensors are emitting data and you need to do some predictions on top of that. So it is a real-time thing, right? So it has to be ingested in real time. There cannot be any latency. While latency based would be like customers making purchases from a commercial store, and commercial store at the end of a business day want to transfer that data to the analytics platform. So there is a latency of, let's say, 12 hours or 24 hours introduced into the data being ingested. So different use cases, so different needs, right? And how much data security is needed, because there are heavy regulations that are in place in different geographies, right? So GDPR is one such example. So it's important to understand the implication of the data that you are ingesting, especially from the standpoint whether it's a personal and identifiable information, or is an ordinary information. So appropriate regulations are there, and an organization need to be very thorough about what they are ingesting. And there are cases where companies and organizations have ended up paying heavy dollars, in terms of fines being imposed by the local bodies. So that is again important metric to be taken care of, and how much you are storing raw, and how much you are archiving, how much you are curating for your end users. All these questions needs to be answered before you start your ingestion journey. So any questions till now, or shall I move to the next slide that I have? Now, before we talk about data lakes, I would like to introduce the concept of data warehousing, the concept of data marts, and the concept of ETL, extract, transform, and load methodologies, which were part of the industry. If we talk about like 10, 15 years back, I myself have worked on, systems like Informatica, Power Center, which were ETL tools. I have done those, those kind of works where we are extracting, we are having some transformations, and we are loading it into a schema that is tightly coupled, that is tightly defined, in the form of a data warehouse, which is nothing but a collection of tables defined, for which designed for optimal querying patterns, that is like denormalized data models. But when we say data models, we are talking about schema that are very tightly defined, and we have to be very thorough when we are loading data into that kind of target system, right? It has to match that format. And ultimately, these kind of considerations slow down the time to, build data marts, and time to, time to your product delivering value, right? So the new concept is the concept of extracting, loading, and then transforming on the need basis on the user group that wants that data. And that ultimately has given rise to what we call as data lakes. So the methodology is, okay, you ingest as is, it could be unstructured, semi-structured, it could be raw data. You put it in a blob storage, or, you put in there. I'll definitely talk about the options we have in different cloud platforms, but as a general thing, data lake is, it would be the area that will have all the raw data in different diverse formats. I mean, there would not be any restriction on the schema or on the format. So it would be the first stage where you will have all the raw data. You will be ingesting it as it is, and you will be giving access to the different communities that exist in your organization. It could be data scientists, it could be data engineers, it could be a typical business user who is just interested in viewing certain metrics or certain KPIs in a dashboard or in a visualization, right? So you will definitely open up, and you will probably create a data pipeline, process that data into a form, that can help in generate that KPI or that metric. While there could be a population of data scientists who just want to do some data science work on raw data, as like, for example, they may want to ingest that raw data into a data frame, Python based, they can write some Python based code, they want to do some acceleration on top of that. So this is the modern day of doing work. Basically, it has changed. There is a significant shift in the thinking process. Here we are not focusing on transforming first, we are focusing on building a robust storage area that can cater to adjust data from, that belongs to different applications, different schemas, different formats. And ingestion at scale, right? Because scale is also important. Like there could be a records like invoice, medical records, or customer conversations, all that kind of data, and at what scale we can store. So all these are characteristics of data lakes. So any question till now? Okay. So I like having discussed about data lakes, having discussed about the ingesting patterns, I'll quickly embark upon the concept of the cloud market that we have today. Okay, somebody asked one question, can you explain how data lakes are different from database? So Ganesh, I'll answer that question. So databases are tightly, they are tightly defined. There is a set of format, we call it as tables with certain columns, with certain data types, right? You cannot insert data that does not conform to that format. Like for example, there are columns that are datetime columns. We cannot insert numbers in that, right? So there is a hard defined schema, okay? And while data lake gives you the ability to ingest any kind of data, it could be raw, it could be a semi-structured JSON format data, that is, and it could be a CSV format or structured data, right? So it's typically, so difference is you are not deciding schema upfront. You will decide schema when you will start transforming that data. Probably downstream pipelines you will write. Then you will decide. In the data lake, it's like kind of free flow for any kind of data that you are able to store. While databases, a lot of restrictions, relational format, relations between tables, all those stuff, which is not present in data lake. So it's kind of, open to every kind of format that we want to ingest. Okay, so, and then there's a question from Akshaya, that's difference between data mart and data warehouse. So data warehouse is, it could be, having laid on different processes that are existing in the organization. For example, an organization sell products, they do marketing, and they generate invoices, they have inventory of products. All these processes are there in a typical company. Now, data mart typically will be centered around a particular process. Data mart would be, for example, sales data mart that will have some tables that are catering to the information, being recorded by the sales transactions that are happening, while there could be an inventory data mart. So it's basically tied to a process. While data warehouse is at the enterprise level, it's amalgamation of data marts with common set of dimensions, facts and dimensions, if we understand. So Pulkit says data warehouse is ETL and data lake is ELT. You are kind of 80% correct. While there are always edge cases, where we are even doing transformation after we load it into data warehouse. So, but mostly the pattern that you are saying is correct. Yes, Pulkit, you are right on that. And then there is a question from Imesha, which asking what difference between distributed system and data warehousing. See, distributed system is totally different from a data warehouse. Data warehouse, as we just discussed, is meant for data consumption, data analysis, while a distributed system could be, a computation that is performed on a set of nodes, set of machines. Let's say we are running a job that is loading data into a target system, and we are distributing it on multiple machines. For example, a cluster of machines, Hadoop clusters, for example, so that's a distributed. So Hadoop cluster is a distributed system because it has set of clusters, set of machines that can, break up your task and execute in parallel. So that's a distributed system. I hope I answered, I think, almost all the questions till now. So I'll move on. So as we were discussing about the cloud market, the present day cloud market, we have the major players as AWS, Azure, Google Cloud, and then we have Alibaba, IBM, Salesforce, Oracle Cloud as well. a tiny share, but yes. So AWS being the market leader, with a share of 34%. So and I think it's just I always say it's just a beginning. There are a lot of new platforms that are coming as a software as a service platforms like Snowflake Cloud Data Warehouse is there, which is not. So so these statistics are from Statista, and I think these are the statistics in for the August month of 2022. So these are the metrics. So I'll move on. So I will briefly discuss about cloud platforms as a generally before I will take upon Google Cloud Platform specifically. So some of the points I mentioned here, like agility, agility, I remember when I used to work back in 2010, provisioning of a server or a database in a data center used to take 2-3 weeks for provisioning. Now there were a lot of paperwork, a lot of processes involved, and the cost you used to pay was upfront. There used to be a contract that used to be signed between the supplier and the company, and they used to typically agree on a contract of 2 or 3 years. Okay, hey, we will be using your database. This is your license, and these are the clauses. And and there used to be clauses around. Okay, if you want to develop your space in future, these would be the costs you will have to additionally pay, and this would be the time it will take to add space. So it was a very hard defined process, and it was not under control of a single user like me, which is the case in today's time. I can go to a GCP platform or AWS. I can simply go there and I can spin up a virtual server in a matter of seconds. So this is what has changed. This is what I meant by saying agility. So agility has definitely come in the infrastructure provisioning, in the server provisioning, in database provisioning. So imagine the time now it takes to spin up a virtual machine with, let's say, a 16 GB RAM configuration with certain hard disk configuration in the matter of seconds, not in the matter of days. So cloud platforms has changed the equation completely. Now it's not the the process of days, it's the process of seconds. So this so this thing has completely changed the way industry is working now. And importantly, cloud platform is managing that for you. Any service that you spin up, it's a managed service. If it's not completely managed, at least some aspect of it is managed. I'll take one example. If I am setting up a SQL Server database in a GCP platform, I have a service called Cloud SQL that takes care of a lot of things that a typical DBA used to do in 10 years back, like database replication, database backups, database maintenance. All those aspects are inbuilt. Whenever you are buying a service, the platform is claiming, okay, hey, you don't need to do that. You focus on your actual project work. We will do the maintenance for you. We will take care of the backup. We will take care of the fault tolerance. We will take care of the high availability. High availability, when we talk, there are multiple options. Whenever you go for a service, there is an option, like speaking of Cloud SQL as a service, if I want to deploy a SQL Server database, I have an option where I can have my replicas distributed over certain geographies, right? That can help me go global. When I say go global, it's like I have my read replicas in different geographies because my user base is in different geographies. So it's a low latency solution I'm building. So all those features, they are just on, they are available at click of the mouse. It used to be a different story altogether back 10 years back, right? And serverless is another option where you need not be bothering about the server configuration or or the cluster configuration that you need to set up. It's serverless. You just need to run your service, and the scaling and everything will be taken care, behind the scenes by the cloud platform. So I always called it as a secret sauce, the cloud platforms that helps you manage, that helps you build robust solutions, Okay, so now we will come to the Google Cloud Platform, and so here are some of the services. When we talk about the virtual machines, we have compute engine, and when we talk about Kubernetes, we talk about app engine, we talk about cloud functions, and these all are. And then there is, there are two arrows. One says toward managed towards dynamic infrastructure. So if we talk about compute engine, it's an infrastructure as a service. So it's basically the counterpart of virtual machines or the actual servers, that is. So you give some certain configuration, and you get back a virtual machine, which could be running in a Linux-based system or a Windows-based system, right? And if you want to do orchestration on of the machines or the images, I think this relates most to the Docker and other stuff. So I will not go into that detail, but the important aspect I want to give here is like GCP, or for that matter, any other cloud platform, has made it very easy for us to spin up the compute services, spin up the virtual machines with a lot of options available for different use cases. Like App Engine gives you a good, it's a platform as a service, which gives you, for the web application backends. And Cloud Function is a serverless, as I was saying. You need not define any server configuration. You just need to write your code. Let's say if I'm writing a Python now, there is one question. So let's say I am, so when we talk about serverless logic, so Cloud Functions gives you the ability to say, okay, you write your own, piece of code or logic, and do not worry about the, configuration on which will be running. So it's kind of serverless option, so you can execute so you can probably write some event-based data pipeline, executed through Cloud Functions. So before we even go further, just I wanted to show some basics about the cloud platform. I just wanted to say the UI. So just give me a moment. Let me open up a sandbox here. So this is what a typical UI looks like, the Google Cloud Platform. And over the left, you can see a lot of services. These are the different options. As you can see, cloud storage is there, which is the data lake option, as we were discussing. It's a blob storage. It's, kind of, it's the area where you do all the raw ingestion when you are ingesting data into your system. So we'll definitely come to that. Then BigQuery is a data warehouse solution provided by the GCP. And then we have Cloud SQL instances. And before I go there, so I wanted to talk about compute engine. So I'll briefly show like what it means by agility of, spinning up. So this is the compute service we have. Like, here it gives you the ability to spin up any virtual machine on the fly. So you just have to click this button. So you can, so these are the compute options, one of the compute options provided by GCP. And similarly, we have other like Cloud Functional quickly show what it is. So if you see over here, it gives us ability, okay, what is the type of machine you want to select, and what is the configuration you want to give. And over here, if I select cloud function here, so it's basically, see, all we have to do is we have to write our actual code. We have to do our actual project work. We need not be bothered about how it will run behind the scenes, right? We just have to write this code and that's it. We have to deploy it. That's it. So this is the serverless option of doing the compute, right? Now coming back to the discussion we were having. So these are different services we have for storing the data. We have cloud storage, we have cloud SQL, which is a relational database service. It's a managed relational database service. Then Cloud Spanner is another database service. We have Cloud Data Store, Cloud Bigtable for NoSQL options. Then ingestion part, so there are dedicated set of services provided by GCP to do the ingestion for different use cases. Like your data could be a structured data residing in a table. It could be a data residing in a file. It could be a CSV file, or it could be a JSON file. There is a question from Rajesh. Share the lab session URL. I will share. Actually, there is this is from the Quick Labs platform. I'll discuss that later. I'll explain how to use this and how to practice this out. Thanks, Rajesh. So, and then we have Cloud Dataflow, Cloud Composer, Cloud pubsub, Cloud Functions we just saw. Now, Cloud pubsub is a service that is used for ingesting data in real time, like data emitted by the sensors. For example, there is a machine, let's say, the organization is supplying the equipment, certain equipment to measure temperature. And, now the organization is also having sensors to predict whether the equipment is working correctly or not, to do some kind of predictive maintenance, or to, companies these days, they analyze data from these sensors to make intelligent decisions. For example, if the temperature equipment is about to break, there will be certain signals sent out by sensors which can be analyzed, and the user can be notified, hey, your system is about to break down. You need to bring this system back for repair, So predictive and intelligent maintenance is one area where companies are investing heavily. Now other use cases, the ride parks, like big platforms like Disney or other, they have their amusement parks, they have their rides, they have their so what they do is they analyze data from the sensors that are part of these physical machines, these rides, and they analyze it whether and they save cost. Imagine a situation where the ride has broken down in the middle of the business hours, and it may cost thousands of dollars, for a company like Disney. Now, to avoid that kind of situation, the organization are getting into a field of predicting it early and fixing it early before actually it goes in a broken state. So pubsub is a good tool to ingest that kind of data in real time. And then we have tools like dataflow, which is which gives you the ability to build robust pipelines, both streaming or batch pipelines. And Cloud Composer is a very niche tool for orchestrating. Now, orchestration is deciding when to run what. Okay, there was a question from Pulkit, machine failure and maintenance. Yes, kind of. You're right there, actually, Pulkit. So there are sophisticated models, that are fed by the data that's coming from these sensors, and then they do every kind of analysis on top of that before making a decision. Okay, this ride is about to break down, and we need to do some maintenance. Absolutely right. Okay, so coming back, we have Cloud Composer. Cloud Composer is an orchestration service, which basically tells you it helps you define a job, a data ingestion job or a data pipeline job, and it basically helps you define the steps. So it's a managed version of Apache Airflow tool. I hope we all are aware of Apache Airflow is an orchestration service. It's an open source project. And so the good thing about GCP platform is it gives you an easy integration with a lot of open source technologies and tools. For example, Apache Beam, which is again used for transformation and building data pipelines. We have a managed version in the form of Cloud Dataflow. We can deploy Apache Beam data pipelines on Cloud Dataflow as a runner to run parallel data pipelines. Then moving on to the analytics piece, I will not go into the detail of Kubernetes because it's an area separately, more advanced area. I think we should focus only on the mostly used services, in building data pipelines. Then we have for analytics, we have BigQuery. BigQuery is a data warehouse, flagship product of GCP, and they claim to, it's a columnar storage solution. So when we say columnar database is different from the traditional way of storing data, like, platforms like Oracle or SQL Server, traditional databases, they used to store data in a contiguous memory locations. For a single row, data is stored continuously, right? While in BigQuery, it is broken down by columns. Like for a single row, if there are 10 columns, those 10 columns are separately stored. And this optimizes the BigQuery for analysis and visualization, because whenever we are writing a data analytics query, we will be interested in certain columns on which we will be doing aggregation, right? So that kind of setup BigQuery is meant for. And then we have Cloud Dataproc and Data Lab for data preparation, data exploration services. The ML part, again, so we have cloud. So these all are managed solutions: Cloud ML, Cloud TPU, TensorFlow. These all are ML services. And importantly, when we want to serve the data, we have dashboards that can be built in Data Studio. These are GCP products, while there are industry leading products like Tableau and Power BI that can consume data from BigQuery tables and can display, in charts, in visualizations. And if we see over here, we have Dialogflow. Dialogflow is conversational AI. So when I say conversational AI, I hope every one of us have encountered by chatbots. Whenever we go to a bank website or any other website, there are chatbots that are asking us questions. Okay, what is the purpose of your visit, or what are you looking for? All those. So this is a conversational AI, and the services that help to build those kind of solutions, we have Dialogflow, and then App Engine for web applications. So these are like some of the primary services that caters to different use cases. Any question related to any of these services, feel free to ask. I'll briefly pause for 1 minute. And I'll also open my storage. So as we can see, we have a way to organize data. So we will typically be storing data in buckets, which could be any valid name we can give, and it has to be unique. And we can choose where we want to store it, multi-region, or then we have a default storage class, and I'll come to that later. So I think okay, I have some questions. So Muskan asked about Cloud Composer and Airflow usage. So Apache Airflow is a Python-based utility that helps you to write data pipelines. Now, Apache Airflow ships with different operators. For example, if you want to load data into a relational database, there is an operator for that, which is written in Python. And you need to basically write a Python file, you need to deploy it, and you need to run it. But Apache Airflow, typically, if we are doing it on-prem installation, it needs a lot of maintenance. Like you'll have to spin up a Linux machine, you'll have to install Apache Airflow on that machine, and you need to probably decide about what kind of server you want to have, and you'll have to maintain the lot of other stuff. But when we talk about Cloud Composer, it's the managed version. So all the behind the scenes processes, they are taken care by Google Cloud Platform. I'll quickly run you through the screen of Composer as well. So see the difference here. We are not even installing anything. We don't need any on-prem machine. The machine, the configuration, everything is taken care by the GCP. So it's a managed version of Airflow. So it says like it supports Airflow 1 and 2, and then there are two different options. So if I select anything from here, it will take me to the screen where I need to enter certain basic information. Okay, what would be the name of my environment, what is the location, and what image and version, and all those stuff. And on the click of create button, I'll have my instance up and running, which would not be the case if we are going with an on-prem installation. A lot of configuration would be needed in that. So I hope this answers your question, Muskan. So I'll take up Vivek's question. Is only dataflow used for building post streaming and batch pipelines? Well, I would say this is one way to do it. Like, for example, a typical batch pipeline, if I have a requirement, I can build it on let's say I'm writing a SQL in BigQuery and I am orchestrating it through a composer. I do not need dataflow in that case. But speaking of dataflow, they are the industry standards given by GCP. If you want to go for any real-time ingestion scenario, then pubsub coupled with dataflow is the right combination. So it is one of the options, while there are other options as well to build batch pipelines. So, okay, Niaz asked differences between BigQuery and Bigtable. Okay, so the first difference is BigQuery is a serverless option. I'll quickly show the interface of BigQuery. One moment. So go to BigQuery and then I'll also open Bigtable here. So serverless option, when we say, and before we even discuss about that, we have like, it's a NoSQL database service. When we talk about Bigtable, it is suited for OLTP use cases, while BigQuery is SQL based. It's a data warehouse solution, which is suitable for OLAP. So that OLTP overlap shift is there. Okay, and then there are other things that I was talking about, like one being serverless, and in Bigtable you need to define your instance. So these are other ones. So that's it. So let's come back to the cloud storage. So it's an object storage for any kind of data, any amount of data, right? And it comes with capabilities like object lifecycle management, and it gives you options to store data under different classes. When I say classes are typically tied to the cost, that is incurring when you are storing that data. So standard nearline, core line, archive storage, we have for, so let's say if we need data that needs to be accessed frequently, we can have it in standard storage. So it's kind of, this is how the cloud storage differentiate, like how frequently you need data and, what are the options. So core line and archival is definitely if it's the lowest cost, because you won't be accessing your data frequently. You would typically be needing your data for audit purposes or meeting your regulations, which may happen yearly or half yearly. So that kind of data you can have in archive storage. So core line is again 90 days or once in 3 months. So like disaster recovery is one use case, right? And so I'll just I'll quickly show, like, so while you are defining your bucket, you can choose a default storage class. I can go for standard, and then I can even implement a fine-grained or uniform access controls. So I'll go by uniform, and I'll say, okay, create a bucket. So bucket is the top level component, right? Whenever you're going to store your data, and it gives you the ability to create subfolders. Like I can create, okay, test one, and within a folder, yes, you can upload your files. File could be of any type, right? So there is no schema limitations, right? You are free to load any kind of data. So coming back to the slides, I'll briefly discuss about the service called pubsub. Because why I'm discussing these services, because these are the services that are frequently used whenever we are talking about building data pipelines on GCP. Google Cloud Storage would be one service that would anyway be needed to host your raw data. It will be first step in any ELT pipeline that we are writing. So pubsub is another service that will help you ingest data in real time. Like for example, two use cases I have shown here. One is the user interaction in server events. Imagine I am browsing a website. Okay, Amazon, for example, I am browsing Amazon website and I am ordering something, and I stopped midway. I went to the checkout stage and I never made the payment because somehow, for some reason, I was not convinced. So I left that in between. Now, what happens is, this interaction that I've done with the web platform, Amazon, this is analyzed basically in real time. Typically what will happen is, there are teams that are sitting in Amazon who are analyzing my click stream. Why a typical user didn't check out and purchased that? What could be the reason? Like, after analyzing, let's say they are analyzing my click stream, and there could be a downstream action where they might be sending me a message on my mobile phone or on my email. Hey, you were browsing your website on this day and you were looking for this product, but you were not able to complete your transaction. Can we help, or can we provide, or a company can provide you, okay, you were buying this product, we are giving you this much discount. So this is the intelligent reporting and operational reporting that is happening these days, and it is happening in real time by the tools like pubsub. So pubsub is an equivalent of Kafka, if we say Apache Kafka. So we have a counterpart in GCP called as pubsub. So IoT devices we already discussed. So, and dataflow is building your data pipeline, stream and batch data processing. It is serverless. We don't need to configure any cluster or instance. We just need to create our job. That's it. And it's a fully managed data processing service. And behind the scenes, there are servers, virtual machine compute engines that are running whenever we are running a data flow job. There is a horizontal auto scaling of worker resources. Like there could be 2, 3, or 5 virtual machines that are running behind the scene, depending upon the workload, depending upon the volume of data that is being processed by the data pipeline. So it all happens, behind the scenes. There is nothing we are configuring. So this is a very useful tool for stream sensor data processing, and it make use of Apache Beam SDK. We can write number of transforms using Apache Beam, and we can deploy it as a cloud data flow job, which can run on a parallel system. So BigQuery is the target system for any data pipeline that we build on GCP. Most of, for any data warehouse requirement or any BI reporting that we are doing. So we will have certain tables created in BigQuery that are loaded by a data flow job. For example, it could be a data flow job. Typically, it could be a writing to a BigQuery. It could be a streaming insert, in real time. There is a high-speed streaming insertion API, that is provided by BigQuery that basically lays the foundation of real-time analytics. So typically there would be a job, that is running, ingesting data from pubsub, and transforming it through dataflow and loading it into a BigQuery table in real time, because we have BigQuery real-time insertion API. And imagine the dashboard that is reflecting changes in real time. So pubsub, dataflow, and BigQuery are the key services mostly used, to build data pipelines on GCP. So I'll show one diagram, and I'll thank Google advocate Priyanka Vagaria for this image, nicely built here. So it basically tells you, what goes in a typical data analytical pipeline, right from capturing, processing, storing, and analyzing. And it covers the services like cloud, pubsub, if you see on the right side. And it gives you, a lot of other options, like IoT Core is another service. But I think we talked about pubsub, and then there are services like cloud dataflow, which falls in processing section. And then while we are storing, we have BigQuery and we have cloud storage, Google Cloud Storage, right? We discussed about these solutions. And analyzing part is taken care by BigQuery itself. And then there are certain use cases like AI, TensorFlow, Looker. Looker is again a data visualization tool, which is GCP native. So a lot of consumption use cases are there. So this is how a typical data pipeline looks on GCP. So any questions? Let's briefly pause for 1 minute on this slide, and I'll wait for some questions before we wrap up this session. I think we are almost there.
Yes, the time is almost there.
So we have 5 minutes to go, and I think we are almost there. I just wanted to give quick tips here, how to hit the ground running on GCP. I mean, we discussed a lot of services, we have seen, okay, what are the different components, but it's important to understand, like for a newbie, how to start, what are the right steps to take. So GCP provides $300 free trial for 3 months. You can sign up with your Gmail ID, as simple as that. And you just have to provide your credit card information. They would not be charging you anything, but they need it for authentic, authenticity. And you can have that, trial account up and running for 3 months. You can practice and play around with a lot of services. And then there is a Cloud Shell editor, where you can write the CLI commands and scripts to interact with different services. Okay, somebody asked, can we use debit card? I think you can use, but I have not, although I have never used it, but I always use credit card, but yeah, depends. You can try probably. So another important resource to practice is Quick Labs, and I'll quickly show. So this is what the Quick Lab is. It gives you a lot of tailored labs that you can work on. Again, it is 1 month trial that you can sign up without paying any cost. Okay, so I have there is a catalog of different services, as you can see here. If I go, this is the Quick Lab platform I have, and you can select. Okay, let's say I want to learn some data engineering stuff. Okay, I'll search it out, and there will be set of labs, quests that are available to do data engineering. As you can see, there is a quest. Quest is nothing but a collection of labs, hands-on labs. So step-by-step labs you can perform. Okay, and it gives you a sandbox that you can practice on. So this is another useful resource. And yes, and the next step is, of course, reading the official documentation. I know nobody wants to read documentation. It's lengthy and comprehensive, but a lot of the official stuff and features, that gets updated, they are reflected in this official documentation. So it's always a good practice to learn and understand. Reading is not a bad habit after all. So reading official documentation gives you a lot of good insights. Then the first step is like after, you should prepare for associate cloud engineer exam and be certified. That will give you a lot of edge. So I have included the URL that gives you the detail about this exam. It's a basic starter exam that you should give. And I have, okay, I'll be sharing this slide anyway with the data, with the team here, analytics with the team, so they can probably share it with you further. And
yeah, sure.
I have a question from Vivek. Data from BigQuery gets consumed to develop ML pipelines. Yes, that is correct, Vivek. Because data, see, BigQuery is used for consumption of data. It could be for different use cases. TensorFlow is one use case for that. Okay. And then there's a question from Rajesh in Quick Labs. Can we use all services? I think we can use most of the services. There is no restriction as such. Yes, I think the answer, while some of the new services that may not be in general availability or something, they may be restricted, but I never encountered anything of that sort. Most of the services are available for you to practice. Okay, any other questions? I think just 1 minute to go before. Okay, there is a question from Midun. Is it advisable to move our existing services in Amazon Cloud to the new Google Cloud that ever? Well, it all depends how much of effort. See, I am not saying there should not be a preference to any cloud platform until and unless there is a solid use case at hand in terms of cost reduction, in terms of the edge that you are getting in terms of the availability or in terms of the latency reduction. All those evaluations need to be done before, because every platform, cloud platform, whether it is AWS, Azure, or GCP, they are providing competitive services. So we cannot say, okay, hey, this service, for example, a virtual service, a virtual machine, it's not good in AWS, but it's good in GCP. These services are equivalent. But yes, definitely we need to find that use case that fits, like, okay, in terms of cost, this is better. Then we can make a move on that. And also migration challenges we need to explore, like how much is the challenge to migrate an existing service from AWS cloud to GCP, all those. Okay, so any other question? I think we are there. It's 2 o'clock, so.
Yes, we are there. Okay, so there is one more thing. I have shared the feedback poll, so kindly fill up that. And for any more questions, please feel free to ask.
Open for questions. And audience, really nice questions you put up today. And yeah, please feel free to, you have my LinkedIn profile anyway, shared by Archit, I think. So please feel free to ping me as and when needed. Okay, there is a question from Farzana. Farzana, where have you posted the question? Sorry, I missed it. Can you repost it? There was question from Niaz. For ML practices, which GPU instance is used? I don't think we'll have that information. You'll have to check like that specific lab that you are exploring probably. And I think there are restrictions. Okay, there is a question from Farzana. Can we archive old data, reduce size and retrieve? Yes, of course. So we have archival class for that. Now I'll quickly show like, we have that, if you see in the last line, archive storage is there on my slide here. It is used for archival. Let's say if we need data probably 2 years down the line, we can have it stored in archive storage class. It'll be from cost perspective also, it will be very good to have, your data stored in there. Yes, we can do that. I hope that answers your question. Okay, so, okay, I have a question. Can we remove chunks of data? From where, Farzana? So if you're saying removing from Google Cloud Storage, yes, we can build pipelines on that where it will pick up only data meant for certain date and not pick up for other date. Yes.
Okay, I think we should wrap this session up now. So thanks a lot, Jaspreet, on behalf of Analytics Vidya. I would like to thank you for your time, for delivering such a wonderful session. It was quite an interactive session. So I'm sure the audience find it quite insightful, and we'll be conducting much more sessions like this in coming days. Okay, so this recordings will be available on our YouTube channel, and for more sessions, we have already shared the link. Now I think we have few more questions. We can
Right.
take a minute or two answer them.
Yeah, sure. So the question is, can you propose GCP for a bank's analytics framework? Yes, we can. But since in a bank, we will have a customer transaction, the money getting transacted. So there is a personal information involved. So we will have to ensure all those redaction or, what we call it as like, the data is properly redacted and encrypted. All those things, there are services provided by like DLPs there in GCP that basically redact the data like credit card information or, the bank information, bank account information. So all those pipelines you'll have to include. Yes, we can definitely do, because banks do make use of GCP, like HSBC is using GCP heavily. Yeah. There are other international banks that are using this. So GCP is definitely not GCP, every other platform. It all depends upon how much cost and what is the use case, at hand. I hope that answers your question. Okay, thanks, Sharif, for your comment.
Thank you. Thanks a lot for all of you, and thanks a lot, Jaspreet. Okay, so everyone, I think they have filled the feedback poll. If not, please fill it up.
And I would like to thank Analytics with their team and all the participants for showing the curiosity through the questions that they're asking. Really wonderful questions. And yeah.
Thank you, Jaspreet.
So thanks all for your time. I think it's good to wrap up right now.
Yeah, okay. So I'll just end this session.